Hello, my name is Andrew Hebda, and I'd like to welcome you today to a new program on Cable 10. It's called Science is Your World. Now, you're probably aware that there was a program previously presented on this network called In Harmony with Nature. We covered a wide variety of topics related very much on natural themes and topics, but we thought perhaps it's time to spread the context of the program a bit and introduce some basic concepts in science and things related to our world in general that may be of interest to you. And that's not to say we'll be getting away from natural topics strictly by themselves, but we thought we'd perhaps present you with a little bit more information. And as a special treat, in our inaugural program, we have with us Dr. Mary Ann White, who is a professor of chemistry at Dalhousie University. And she has brought together a presentation on something perhaps that most people don't think about. It's accidental discoveries in science. It obviously leads the question that science isn't necessarily following a specific order in research and hypothesis testing, but interesting things happen just out of the blue on occasion. So, Mary Ann.
Okay, thank you very much, Andrew. It's a pleasure to be here, and to perhaps tell people a little bit about some of the things that happen in science that are really not planned. And often when we look at things after the fact, we think they were all planned perfectly. This is exactly what we planned to do, and this is exactly how things turned out. But this isn't always the way things are in science. And quite often in science, we have concepts that have come about for purely accidental means. If we look at the first overhead, we could see what the scientific method involves. Scientific method that we're usually taught about in school involves thinking that there is some purpose to an experiment, and from that purpose we form a hypothesis. We make some method, we maybe build some apparatus, we form some observations, we draw some conclusions. If they don't meet the hypothesis that we had, we go back and we have a new hypothesis. We go through the method, apparatus, observations, and conclusions over and over again until we begin to learn how nature works. Now, this is often how science does work, but sometimes those observations that we've made going through our scientific method lead to something that is really quite different from what we had expected. And in fact, if we think about some of the great observations that have been made in science, the great observations that have been made in science have sometimes led to quotations, like this quotation shown by Louis Pasteur, that in Pasteur's words, and I'll say it in English rather than in French, in the field of observation, that is in the field of science, chance only favors the prepared mind. And really what Pasteur meant here, and we have a picture here of Pasteur working away in his lab. He was a very bright scientist, very great contributor to chemistry. What he meant is that sometimes people make observations, and those people, although they'd made an observation that somebody else could have seen, if their mind wasn't in the right frame, then they could have missed that importance of this observation. Pasteur's work itself, in fact, is a good example of this. One of his greatest discoveries had to do with arrangements of molecules in crystals, and he sorted out two very different but similar types of crystals, and it turns out this work was made a whole foundation for a new area of chemistry. And it turns out that if the temperature of his lab had been 2 degrees hotter, he wouldn't have been able to make these observations because those crystals wouldn't have existed.
This is actually quite interesting because, of course, most people consider Pasteur to be the classic microbiologist. And
yes, well, Pasteur was one of those scientists who lived in a time when scientists could make contributions, major fundamental contributions to many fields. As you can see, he lived in the 1800s, and now we tend to classify ourselves a bit more. But I think not all scientists are totally classified in particular directions. Turning to physics, I can quote another example with a classic example that a lot of people know of, Sir Isaac Newton's discovery of gravity. And a lot of people have thought of Sir Isaac Newton and this apple falling from the tree in the law of gravity, and how the law of gravity says that two masses interacting a distance apart from each other exert a force we now call gravity. And in fact, a lot of people would say this was a classic case of an accidental discovery in science. And I'd like to just read you a quote from one of Newton's friends, Dr. William Stuckley, who was a physician and a personal friend of Newton, and he described a conversation that he had had with Newton about this episode of the apple falling from a tree and how this began to turn the wheels in Newton's head, thinking about science. Stockley wrote, "After dinner, the weather being warm, we went into the garden and drank tea under the shade of some apple trees, only he and myself." By the way, this observation was made at Cambridge University in England, and they say that apple tree still exists there. Amidst discourse, he told me he was just in this same situation as when formerly the notion of gravitation came into his mind. It was occasioned by the fall of an apple as he sat in a contemplative mood. Why should that apple always fall perpendicularly to the ground, thought he to himself? Why should it not go sideways or upwards, but constantly to the earth's center? That shows how great Newton's mind was, that he realized immediately it was going to the earth's center. Assuredly, the reason is that the earth draws it. There must be a drawing power in matter, and the sum of the drawing power of the matter in the earth must be in the earth's center, not in any side of the earth. If matter thus draws matter, it must be in proportion of its quantity. Therefore, the apple draws the earth as well as the earth draws the apple. That there is a power that we call here gravity, which extends itself through the universe. So in Newton's case, again, it was just accidental that he happened to see this apple fall, and it really began to make him think about gravity.
That's also interesting because, of course, Newton was noted for his total and utter lack of sense of humor. He was noted to have only smiled, I think, on 2 occasions, and one being when his most hated rival died, I think. So interesting to see the degree to which he managed to keep his mind focused on analytical mind focused on an observation.
Well, he was a very serious person. He was a very serious scientist, and maybe I'll just tell you a little bit about Newton as a person. As a young person, he wasn't an outstanding student, but what really changed his mind was during the plague. He was forced to move home to the country, come back from school, and he spent 2 years at home doing nothing but studying mathematics. He was a weakly child and couldn't work on the farm. So he did nothing but mathematics for 2 years at home, and that really, I think, laid the foundation for him for life.
Very good. Yeah.
Another example concerns, in this case in the field of what we now call immunology, though there was no such field in those days, concerns the case of Edward Jenner, 1780, and his discovery of the first vaccine, and it was a vaccination for smallpox. Now, the accidental discovery here comes about because Jenner was told something that he really listened to and paid attention to, and about 20 years later first used in a scientific way. When Jenner was studying to be a medical doctor, at the age of 19, he was told by a former milkmaid that she couldn't get smallpox because she'd already had cowpox. Now, we don't talk about smallpox these days as being a big problem, but in those days, smallpox was a very big problem. In fact, more people have died from smallpox than anything else except the plague and one other disease that I can't quite remember the name of at the moment. But it's really been a very devastating disease over millennia. Now, Jenner was told this at age 19, and he didn't understand why this was, though this was common folklore among farmers, that if you'd had cowpox, you couldn't get smallpox. When he was 30, he was doing research on this subject and found that there were 2 types of cowpox, and only one of them prevented people from getting smallpox. And by the age of 47, nearly 30 years after he had first heard this chance observation, he tried an inoculation of a person with the pus from cowpox vesicles, and that prevented people from getting smallpox. And this led to immunization and the understanding of the immunity system.
And the eventual, of course, elimination of smallpox as a disease, yeah.
That's right. Yeah. And, of course, immunization has led to the prevention of many other diseases that besides smallpox as well. So it's led to that whole fundamental understanding in that field.
So this vintage would have been about a little bit post Pasteur, that eventually would it, or would it have been
actually he was
comparable time?
Just a minute.
Yeah.
Pretty well pre-Pasteur.
Okay, so quite early on then.
Yes, quite early on, around 1830, 1840. Early in Pasteur's scientific life, very early in his scientific life. Next example that I wanted to mention to you concerns the discovery of a particular type of antibiotic. And this type of antibiotic was found purely by accident, and it was only really by accident that this was pursued by scientists. And this story all starts out, believe it or not, in a sewage outflow in Sardinia. Now, this doesn't sound like a very likely place to make a scientific discovery, but there was a scientist working in Sardinia whose name was Giuseppe Brazzu, and he found that there was a particular type of I should say first off that he was a professor of bacteriology in Sardinia, he found that there was a particular type of fungus that grew only in this sewage outfall in Sardinia, and he found that it had antibiotic properties. It's just in regular screening of this that he found this to be the case. And he tried very hard to interest Italian pharmaceutical companies in this type of material, and none of them were interested. I'm sure now they're quite sorry that they weren't interested. This was 1948, and there were a lot of things going on in the world, and this was probably the least of their concerns at the moment in Italy.
His background was he was a chemist, was he? An analytical chemist?
He was
or
a
health
bacteriologist.
I see.
Yes. And he reported his findings, nevertheless, to a former British public health authority who brought them to the attention of Edward Abraham, whose picture you can see here now. He's now Sir Edward Abraham at the School of Pathology in Oxford University in England. Now, Sir Edward Abraham had worked on the same team with Florian Chain, the team that had discovered penicillin and its antibiotic properties. And Abraham realized immediately the importance of these cephalosporins. And in fact, this picture is taken from a newspaper when it was announced in 1982, that Sir Edward Abraham on his retirement was going to be knighted by the Queen for his work on cephalosporin. People at Oxford University all know this word cephalosporins because Sir Edward Abraham has given pretty well all the profits from cephalosporin to a cephalosporin fund to support research at Oxford University in England, and it's some many, many millions of pounds.
This is quite unusual, yes.
Yes, so really he's a very much a person who believes in carrying on scientific research. And I should say somebody who I have met personally as well. It's my husband, who's also a scientist, in fact worked with Sir Edward Abraham. He's a very interesting fellow. I would call that example somewhere between biology and chemistry, not that we should necessarily categorize science, but the next one I'd like to tell you about is the discovery of nylon. Now, we all know that nylon is very important in our everyday lives. When I was a kid, people used to talk about wearing nylons, but in fact, we now talk about pantyhose, not nylon so much.
Same material, different material?
Very much the same material, very similar material. But before I tell you about nylon, maybe I'll first just tell you a little bit about what polymers are. I thought you might already know. If we think of a molecule as being like a little person, we could think about this molecule being one small person by themselves. If we think of a small person holding hands with other people, as in these paper dolls, now we have a long chain that can have different properties from the individuals. So if each of these people is like a molecule, when we have them all joined together, we can form what's called a polymer. And these polymers can have some very special properties, particularly sometimes the property of very good strength. In the case of nylon, this is the case.
By the way, Marianne does point out that this is not something that's generally done within the Department of Chemistry at Dalhousie. This is a teaching aid.
Yes, purely a teaching aid. We don't spend much of our time cutting out paper dolls. Anyhow, nylon was discovered at the DuPont Chemical Company, and there's a picture on the overhead of the chemical structure of nylon, part of the nylon polymer. Nylon is the trade name for this polymer. And this polymer, there you can see the long chain, this polymer was first discovered by Wallace Carothers in 1938. Now, Wallace Carothers was trying to make a new type of polymer, but what he found was this material that he made was really just a goopy mess. And this is really a frustration for a synthetic chemist. And in fact, he really didn't know exactly what he should be doing with it. This is a picture of Julian Hill, who's a colleague of Carothers, and he's reenacting a special discovery of how to handle the properties of nylon to make it useful. In his one hand, he has a container with nylon, and in the other hand, he has something that's pulling this out, and this is a cold pull or cold drawing effect for the production of strong nylon fibers. Now, this was really discovered by accident. The accidental discovery here comes about as follows. Carothers was the lab boss. He made this stuff, or maybe his team made this stuff, and it was very goopy, and it wasn't what he wanted. Well, one day, Carothers was downtown doing goodness knows what, but Hill, who was shown in that last picture, and his cohorts, decided they would see how far they could stretch those samples of nylon. And they took it out in the hall, and they formed a ball with it, and they started horsing around with it, really, out in the hall of the lab when their boss was away. And they started stretching it, and one of them ran down the hall with a ball of this. And they found as they stretched it, it aligned the molecules. It aligned the molecules just as with these paper dolls again. Here they were all now lining up. So this fiber was this way and another one this way. As they pulled them out, they all lined up like this. And they had fantastic strength as a result of this. if you haven't heard this, it might be useful to know this, that nylon stockings are so strong that if you dump your car in the ditch by accident, you can tie a pair of pantyhose around your bumper and around the bumper of something else, and they'll stretch, but they won't break. Nylon rope is also known for being so strong, and that's because those molecules are all lined up. But it was purely by horsing around that they found that these molecules were so lined up.
Nothing to do with the University Tavern being down in the next building over, I don't think.
I don't think it had anything much to do with that. But anyhow, this was truly an accident. I guess they had to be pretty brave then to tell their boss when he came back from downtown they'd been horsing around with this out in the hallway.
Although it would be difficult to get it all back into the same goofy ball to begin with.
Yes, I can imagine. Yeah, I can well imagine. The next accidental discovery that I'd like to tell you about is also a product that we now see quite often, and this was discovered, in fact, in the same year. And this is another product that's polymer, and this is the polymer we call Teflon. This was discovered by another chemical company, also by accident. Must have been a good year, 1938, for accidental discoveries. Glad to know I wasn't born that year. You might think it was by accident. But anyhow, this is the structure of Teflon shown here. And first, there's the picture of the monomer. That's like the one person in the paper chain.
Mm-hmm.
And then the next picture of the structure shows that there's all of these stacked together in this polytetrafluoroethylene, which we commonly call Teflon. And this was discovered by Roy Plunkett at DuPont, and it was discovered in a very accidental way. DuPont was interested in that first molecule, which is a fluorocarbon, which we now know those are things that eat up the ozone layer.
Mm-hmm.
And they were interested, DuPont was interested in this as a refrigerant. And they were studying the properties of these molecules as refrigerants. And they had these molecules in what we call a lecture bottle or a small gas bottle, about like the gas cylinder you'd have for a propane barbecue.
Mm-hmm.
And Plunkett found one day when he went in to do some experiments on this refrigerant type of molecule, he opened the tap and nothing came out. Should have been a gas, it should have come out. And he thought, this is rather odd. Now, he did something that is what we call following your nose in science. I'm sure you know what this is all about. He decided that he would weigh the container. He knew what the weight should be empty, and he knew what the weight would be then, and he could see whether it really was empty, because he was pretty sure it was quite close to being full. Well, he weighed it, and he found, indeed, there was weight inside, mass inside there. There should have been something there. So he did something even more following his nose. He just wanted to know what was going on here. He cut this open, this container, and inside it he found a beautiful, waxy, white substance. And this is the substance that we now know as Teflon. And it turns out that it was converted by a chemical reaction right inside the container into Teflon, and then they had to figure out how it actually happened. That took, in fact, the DuPont company a lot longer to work that out. So again, it was an accidental discovery. This was not at all, he was studying refrigerant. This was not at all what he had set out to look for in the first place.
Did he receive full credit for it? Or?
Oh, yes, the DuPont company, as full credit as a company gives their employees. I'm sure he had bonuses and so on, but, and the rights all went to the DuPont company. And it's certainly a multi-million-dollar industry now. Though, in fact, Teflon, you'll notice that it was discovered in 1938, and in fact, it didn't hit the market, the general public market, until the late 50s or early 60s. And the reason for that is that almost all of the first applications were saved for military-type applications.
As I think with most substances, even nowadays, once we exhaust the military applications and the space applications, then we look to see how we can make money on it.
Well, maybe. Anyhow, Teflon's very useful material now. It's used for spare body parts, like new hip replacements and so on, biomedical applications, spacesuits, electrical insulation.
And, of course, politics.
Yeah, well, there you go. Yeah, that's what's so good about it. Things don't stick to it, that's for sure. I'm going to tell you about another chemistry accidental discovery. This accidental discovery involved something that took place about 100 years ago, and it was a competition between two chemical companies that were trying to make a very important dye, indigo. This dye, indigo, is called the king of dyes, and it was one of the very first important dyes known. And it's a dye that is used almost everywhere these days. Certainly when I look out in my lecture theater, I could see lots of indigo dye and the dye of blue jeans. And it's still a very important dye. And until that time, the 1890s, it wasn't possible to make indigo in the lab. Indigo had to be extracted from plants. And this wasn't really as feasible as making it in the lab if a company could work out a good way to synthesize this in the lab. Well, I don't want to tell you about all the details of the synthesis of indigo, but there were two big companies, BASF and Hoechst Chemical Company, that were competing with one another to try and make indigo. And the long story is that they were trying well, the short version of the long story is they were trying to make this. Both of them were trying slightly different routes, and one company was really stuck. They were trying to work with some really nasty chemicals to try and make indigo. And they had something accidental happen to them that was a wonderful thing as far as they were concerned. They were in this reaction trying to make this. They had a mercury thermometer, and as the reaction was going on, the mercury thermometer broke. And rather than throwing that out and starting over, as a lot of students would do, a lot of scientists would do too, they decided to do something different. They decided instead to look and see what had happened after the mercury had broken and whether things had worked out. And it turned out this reaction is helped along by the presence of mercury.
So the mercury catalyst was the secret in the,
That's
in
right.
the brew.
Yeah. Actually, mercury's not the only, this is not the only case of mercury being important in an accidental discovery of science. There's another example in the early photography. Early photographic plates were produced, but they didn't have very high quality. And one of the early people in photography, whose name was Daguerre, a Frenchman, he found that some of his photographs developed better depending on which cupboard they were in. And it turned out, when he investigated further, that mercury vapor from broken mercury thermometers in one cupboard happened to help out his preparation of photographs. And that was, again, an example. Now, I think there are lots of examples. I've tried to give you quite a few historical examples. Yes. And I think almost every scientist could tell you about something that is accidental. Maybe you could tell me about something that's happened to you accidentally in your lab.
Oh, we have no accidents, of course, but I was just thinking on TV they have those adverts for those little Post-it notes, which again was an accidental spillage of a...
Yes, and I understand at first 3M didn't know what to do with this, that they weren't really sure what good these things were because they didn't stick very long to things. And then somebody said, well, why don't we try them on things where they shouldn't stick very long? So again, it's a matter of having a prepared mind, as Pasteur had said. We discovered something in my research lab a few years ago that was what I would classify as an accidental discovery. And in this particular accidental discovery, we were trying to make materials that would store energy very well. And we started with one type of material and we worked our way to another type of material that was the type that we had designed, thinking they would store energy very well. And in fact, it turned out, although we made a whole series of these and looked at them all, they didn't store energy as well as we thought they would. But the student who was working on this project, who's now received his PhD, his name is Mike Van Oort, he decided, well, rather than just looking at the starting material and the ending product, what about this thing we have to make as an intermediate? Let's just have a look at those, see how they store heat. And it turned out those stored heat wonderfully. And this application is now, we hope, going to make it actually to the marketplace on those materials. So again, that's a case of an accidental discovery. And just being aware to think of, well, what if?
What if, what can one do?
Yes, that's right.
Are these types of discoveries limited to pretty well the scientific community, or a little bit broader in general?
Well, I suppose if you want to take the whole field of lateral thinking, that is, starting with one thought and then just letting some free-range thoughts come in, I suppose one could reach accidental discoveries in pretty well any field. That I don't think it should necessarily be limited to science. But I think a lot of people have the view that science is this, then this, this, then this, this, then this, and so on. And it is to a large extent. Sometimes it's through hindsight.
Yes.
We did all these other things in between, but then we say, okay, now looking back logically, what we really intended to do was this, but it may not actually have been what we set out to do.
Yeah, it's time to rewrite the paper quickly, or the abstract anyways.
Yes, yeah. I think that's quite true. I remember hearing a case when I was a student of a chemist who had actually not made the compound he intended to make in the first place, but did a lot of measurements on it, and then found out it was something else. But he started the paper in our continuing studies because that happened to fit in with another area of his research. The last example I wanted to tell you about is an example that I guess it's accidental, where you could find these accidental discoveries in science. I actually read this in the Air Canada magazine on the airplane, where they sometimes have some interesting business examples. And this example involves a rust remover. And the rust remover was found because a farmer had left an axe, a rusty old axe, by accident in a bucket of potatoes. And I don't know why he left the axe in the bucket of potatoes, but what he found after he left it there for a few days was that the axe no longer had the rust on it that he expected it to have. Now this is really important because its importance was noticed by somebody who's a chemist at Dearborn Chemicals in Mississauga, and he found that this was important because you could use this to remove rust. Now, the important thing is that it works at neutral pH. That is, you don't have to use strong acid or
Quite
strong
unusual,
base.
yeah.
And I'm not sure if they know yet what it is about the extract from the potatoes that removes this rust, but this is now an industry that was $2 million in annual sales last year, and this extract from the potatoes is now included in pipes in various places, like Scotia Square in Calgary, for example. And this was, again, an accidental discovery.
Just imagine a number of our viewers heading off to the kitchen right now and into the implement shed to clean up some.
Yes. Yes. So I guess it's a matter of you never know where these accidental discoveries are going to come from.
Mm-hmm. Very good. Well, how would you, if you had a moment or two to sum up your thoughts on science, accidental discoveries in science, and whether or not are we being a bit too rigorous nowadays, or perhaps too critical of our research to actually keep our mind open to such incidents, as it were?
Well, I think we should always have a broad mind in science. I think we shouldn't just call ourselves particular types of scientists and think that that's the only thing that we can possibly be interested in for the rest of our lives. But even broadening it further to students of science or lay scientists, so to speak, I think that when we're observing things, no matter what we think we're aiming to observe or what direction we think our observations are going to go in, I think we should always keep an eye out for other things. There's nothing wrong with rediscovering something that somebody has already discovered. Sometimes that's important, that some accidental side spin may rediscover something that somebody knew 100 years ago, but that knowledge might almost have been virtually lost, maybe in the library, but nobody has been looking at that for some time. They bring it back to light.
Or some practical applications known on the farm or out in the field that have no bearing on modern life and in actual fact are quite important.
That's right. Or some aspects of modern life that might have changed, that our whole look at magnetic materials might be different now from what it was 50 years ago when we didn't have CD players and all sorts of things that use these sorts of new materials. So I think generally we have to be as broad as we can. All of us thinking in all our directions have to be as broad in our thinking as we can. And science is our world, I guess, is a good title for this show, because it's true that science is all around us. The logical rules of nature are all around us. And that's the purpose of science, is to try to understand these logical rules of nature. And sometimes in doing that, you have to really keep your eyes open
for the unexpected, as it were.
For the unexpected, yeah.
That's very good. In your own laboratory right now, are you, say in our last minute of rounding up, are you keeping your eyes open, or are you teaching your students then to keep their eyes open and their mind open for that?
Well, I think we should always tell our students, to teach our students by example, to keep our minds open, because you just don't know exactly where you're going to find things. And if you find something that is totally unexpected in whatever sort of measurements you're doing or systems that you're examining, you should be asking yourself why. You shouldn't ask yourself first, does this have relevance to what I'm looking for immediately? But even if you keep a file, as certainly I do, of future prospects as things crop up, then I think that's very useful.
Very good. And don't discard your data. It may mean something.
Oh, never discard your data.
Well, I'd like to thank you very much, Marianne, for coming and showing us that science has many other dimensions than strictly test tubes and flashy equipment. It also has that aspect of what's going on back here and how we perceive it. And so with that, I'd like to thank our viewers for coming and seeing our first program of the year.